Hi dear folks, today's Leetcode challenge is kth largest element in an array. In today's problem, we are given input as an integer array and a value of k, and we have to find the kth largest element in input array. For example, we are given input as this array of integers and a value of k is equals to 2. Then if we'll sort this array in descending order, we will be getting output as 6, 5, 4, 3, 2, 1, and we have to find the second largest element here. So first largest element in this array is 6 and second largest element in this array is 5, which is our output. We can solve this problem using three techniques. One is just a simple one. We can sort the input array using arrays.sort, and then we can find the element at n minus k index. For example, using arrays.sort, we'll get the input array as 1, 2, 3, 4, 5, 6. As this is in ascending order, we need the element present at fourth index here. We can calculate fourth index using formula n minus k, where n is equals to length of input array. In this case, it will be 6 and k is the given output, which is 2. So we need to return nums n minus k, or nums at index n minus k, which will comes out to be nums 4, and its value is 5 here. The time complexity of this approach is n log n and space complexity is O1. Let's move to the second solution. Second solution is a variation of quick select algorithm. In quick select algorithm, we know that we get a pivot index, and that index has element at correct position as it should be in a sorted array. So we will check if pivot index value is equals to k minus 1. Then we know that we got the answer. We'll return the element present at pivot index as an output. Also further, if we didn't get pivot index is equals to k minus 1, then we will choose the property that elements to the left of pivot index has value smaller and elements to the right of pivot index has value greater than the element present at pivot index. Let's take an example here. We'll start with 3 and we will try to find its correct position in the input array. So as per quick select algorithm, after first iteration, we will be getting array as 1, 2, 3, 5, 6, 4. So here 3 will be at the correct position as it should be in the sorted array, and the value of 3 is 2. That means 3 is present at index 2. Also, all elements to the left of 3 are smaller than 3. All elements to the right of 3 are greater than 3. So what is the expected pivot value here? As we are sorting the array in ascending order, it should be n minus k. What is the value of n here? 6, and k is 2. So we have to find the pivot value as 4. But after first iteration, we got pivot as 2. So we know that 2 is lesser than 4. So we need to go to the right side of pivot element. So we will be playing around array 5, 6 and 4. So we will be taking element 5 and we'll try to find its correct position After the iteration of quicksort algorithm, we will be getting our array something like, so all element to the left of 5 are smaller than 5 and all elements to the right side of 5 are greater than 5. And what is the value of pivot here? It's 4. As the pivot comes out to be expected pivot, so we will be returning 5 as output here. That is the element present at pivot index. Time complexity of this approach is, in worst scenario it is O(n) square, and in best case it is O(n), and space complexity of this approach is O1. And last solution is using min heap. So we will be creating a priority queue and we will be inserting the elements there while iterating over the input array. And when we are inserting the element in priority queue, we'll check if its size becomes greater than k, then we will remove the first element from the priority queue, and at last our priority queue will be just having k largest elements. Here I have created a priority queue. I am iterating over this array and I am adding the element at ith index in priority queue. Then I'll check if priority queue size is greater than k. I'll remove the first element from the queue. Let's start with the dry run here. My first element is 3. It will be added into the priority queue. My priority queue size is 1 and this is lesser than k, so nothing will happen. Next, in second iteration, value 2 will be inserted and priority queue will look like 2 and 3, as it will insert the element in ascending order. The size of queue is 2, which is equals to k, and then it will go to the next iteration. Now my element is 1 and my priority queue will look something like this, 1 2 3, and the size of priority queue is 3, which is greater than 2, and it will remove the first element from the priority queue, which is 1. Now my priority queue after removing the first element will look something like 2 and 3. Similarly, on inserting 5, priority queue will become 2 3 5. Its size will be greater than 2. Then it will remove the first element, which is 2, and after removing 2 it will come something like 3 5. Then on inserting the next element, which is 6, it will become 3 5 6, and this is size is greater than k, and we need to remove the first element, which is 3, and after inserting the last element, which is 4, priority queue will become 4 5 6. Its size is 3, which is greater than k, and we will be removing 4 here, and at last priority queue will be having values just 5 and 6. And in order to get the output, we need to poll one element as well, so it will be removing or returning the kth largest element. Time complexity of this approach is n log n, and space complexity of this approach is ok plus 1 or ok. I have tried quick select and min heap approaches here. Both are accepted by Leetcode. That's it for this problem. Thanks for watching this video, and I request you to like this video as well. Thank you once again.